Hey, this is GarageMan. Today I'm going to show you how I built this custom electrolysis machine for rust removal on large items. This is an 850 watt power supply with 70 amps available on the 12 volt rail. I'm not going to get into how I converted it. There's tons of videos available online. I got it from a friend and then I just tossed it in this old computer case. If you like this video, give it a thumbs up, comment, and subscribe. And today, the first thing I'm going to show you is the item that I removed the rust from.
Okay, so here's what I'm going to be doing. This is the tower to my Coates 5060EX tire changer. So I've got a few pieces in here. I've already done the main cabinet, but I worked out some kinks and got my unit finished, which obviously this video is about. So I'll just show you what I'm doing here. I've got the rebar set up everywhere. Got this rope suspending two pieces of rebar as well. I prefer to keep the attachments out of the electrolyte. So I'm going to connect some coat hangers there and then to all these clamps around. I'm going to come out here a bunch while it's working and use a steel brush with some rubber gloves on and obviously turn it off, and then I'm going to clean those off, but it's going to get really murky in here. You won't really be able to see anything. I'm only going to fill it up to about an inch above this point here, which is the highest point. And then obviously I got to make sure none of these wires, which are attached to the part, touch any of the rebar, and that the rebar over here doesn't touch anything. So make sure I'll get all this finished wiring up. I got to get obviously all the wires attached to these. And then once I have everything set up, I'll continue along with the video and show you my unit. Okay, so I'm about to turn this on, and here's the tub. So it's connected negative to the part, obviously, and positive to all that rebar. And then I have it going with 0 gauge wire that I had through this male slot to my modified computer power supply, which I will do another video where I open up the side and show you. I just wanted to show you the power on and turning all the switches. So I'm not sure what kind of current draw this setup is going to pull. So I have all the switches in the off position, and then on this side over here I have all the light bulbs. So I'm just going to flip the switch on and it's booting up. So as you can see, I have 12.21 volts at 0 amps. And that's because all the switches are off. So as I turn one switch on, the light comes on. We've got 12.2 volts still. It's pretty stable. It's a computer power supply, and I'm only getting 3 amps going to that entire unit outside. And on this side, it's obviously very bright, there's one car light bulb on. So that is clearly doing basically nothing, and it's because it's such a large part. So I come back here, and I just keep flicking them on. Actually, I'll do them actually here. So obviously got a little dimmer on that side, but we're now up to 7.3 amps. This is now registering voltage. So the difference here in what this shows is this shows the voltage across the electrolysis pit. So these are 12 volt light bulbs from a car. And generally speaking, you have 12 volts going across them. But in this case, I don't. I have just under 10 volts going across those 2 light bulbs. Or closer to 11 now, and 3 volts going across that pit. And the reason that didn't turn on right away is because it has a minimum voltage of, I think, 2.5 in order to turn on. And then obviously on this side, it's hard to see, but there's 2 light bulbs on. So as I keep going, more light bulbs turn on, and the voltage across the electrolysis pit will go up, and the voltage across light bulbs therefore goes down. It's the voltage drop across those. But the amperage is going up, but it's going up at a slower pace now. So still pretty big increments right now. Okay, pretty good there. Okay, so we're at 30 amps right now. So let's go see what's happening out here and see if anything's going on. Okay, so it's probably hard to see, and so it takes a little bit of moving around to get out here. But you can clearly see now that there's bubbles forming. So this is obviously some used electrolyte with some fresh added in. I'm not sure if you can see the bubbles yet, but there are bubbles. But anyways, it's a very big part, so I'm gonna keep turning it up for a bit because I wanna blow off some of that paint. So I'm gonna come back in here and we're gonna turn some more on. But as you can probably see, it's not as bright anymore because the voltage across these, the current is still is getting higher, but the voltage is actually getting lower. So I'm going to show you a chart that I made on the computer after, and kind of shows you a curve of how the voltage and the current are affected. I did this with a different unit that I was doing, bigger than this actually, and I got a nice curve. So kind of showed me that, you know, I could go more than 24 light bulbs, but to get, you know, that extra 20 amp capability for that single part, it would take, you know, another 24 light bulbs, and I just don't want to do that. As well as the fact that, you know, once I've done this with smaller parts, even with all these switches on, you're only drawing, you know, sometimes 5 to 7 amps. So this just lets you limit the top current that you're providing. So if you don't want to put any more than 30 amps, you can limit it. But the maximum current is going to be dictated by a variety of factors, such as the placement of your electrodes, your electrolyte solution. And when I say placement of electrodes, how close they are to the part, and vice versa. How much the concentration of your washing soda in the tub, etc. So anyways, I'm going to turn this up. I want to see what the maximum is on this. And as you see, it's going up pretty slow right now. I'll keep going in a second, but if you see here, it's like a Christmas tree, obviously. Very dim in comparison. At a certain point, I don't know if it'll happen in this case, but these lights, these LEDs will actually go out, and same with the lights on the other side. So we'll see if that happens. It generally happened around here on the other unit I did. So it looks like they might hold on this one. And they did, yeah. So the maximum current that this part with the electrode placement that I have and the electrolyte solution is around 45 amps. Now that's going to fluctuate, and it's dropping, and it drops, or it will drop, and it's going to drop as the rust builds up on those rebar pieces I have. So, you know, pretty steady voltage here, 12.15. So that's the voltage across the entire system. And again, so now across the light bulbs, I have just over 2 volts. The rest of that rest of the voltage is actually going across the electrolysis pit. And then on this side, you can see all of them are on. And you know, because it's such a low voltage now, you can actually stare right at the filament. It does not hurt your eyes to look at it. But anyways, so this is what I did. I had this power supply, or rather I got it from a friend for pretty cheap. I'm going to show you that. I'm going to open up this side cabinet. It'll be in this video. It may have been already in this video. I don't know how I'm going to put this together, but in any case, this is what I built, and I decided this route against getting a welder because I already have 2 MIG welders. One of them is broken, but I don't want to play around with those. I like using them for what they're used for, and the ones I have aren't great quality, so I can't actually individually modify the amperage and whatnot. Plus, I don't know their duty cycles. One of them's super old, it was my dad's. The other one's newer, but it's garbage quality. So the duty cycle, you can't just leave it on at 40 amps steady all the time. Whereas a computer power supply like this, it's rated for 70 amps. I'm only drawing 45 or 46 amps here. I'm perfectly able to just let this run for hours and hours and days, and I'm not going to have an issue. So another thing I added, you can see here, is an intake fan. I wanted to make sure I got proper cooling, thinking originally that the lights were going to be very bright, but they barely gave off any heat, so I'm actually not at all concerned about the heat when I have all these switches on. And then over at the back here is the exhaust fan, and this is the exhaust, obviously, for the power supply. So again, I'll show you in a video how that looks, but for now, you can see, well, it's already covered up here, but you can see it's a much more violent reaction going on here. So the hydrogen's really bubbling up in comparison, and you can see it right here. So I'm pretty pleased with that. It's been working great. I've left it on for a few days for another part I did. And I just come out here from time to time, turn it off, grab a steel brush, and clean off these electrodes, and then fire it back up, and the amperage jumps right back up. So I let it drop. I do that about 2 times, sometimes 3 times a day, and yeah, this is working great for me. Okay, so I've shut it off now, and then I went out here without tripping. got everything out. Everything went really well. I've had it on for just a little over 2 days. Stopped it a few times and cleaned the scale off and whatnot, or the rust. And then, anyways, so I'll show you what it looks like. Hopefully this camera adjusts. It's pretty bright out here. So as you can see, a lot of this paint. So this piece was on top, or around this area was easier for me to get to. So I actually was scraping it with a steel brush. I couldn't see because it was too murky, the water, but in between. But as you can see, this paint, it's coming right off. So I'm going to pressure washer it in a second, and all this paint should come off. I don't really see much rust left on it. It's been eaten away. You know, it is a little bit here, but once I pressure washer it, it should come off and just be pitted steel. And same here. So we'll see how that turns out. Then the other two items I had in here, as you can see over here, one of them I fell in snow, unfortunately. So I didn't actually realize there's a sticker on this one. It was actually painted over. They did really garbage paint job on this to cover up. And anyways, that was underneath. So I tried to peel it off in between because I could feel it when my hand was in there. But anyways, didn't all come off, and there's some stickiness there, so I'm not sure. Maybe the pressure washer will get it off. If not, I'll just have to remove it before painting. Same thing though, they're pretty good. This one you can see some rust, so we'll see after I pressure washer it what it looks like. But all of it was flaky, and the size of the paint that was coming off, I think there's some pieces on the ground over here. No great samples, they've broken up, but some pretty large pieces came off. So this all in all was very successful. So I'll set this up and I'll show you the pressure washering. As you can see, it's clearly done a great job at getting all the paint off. So let's see. Area. Again, I can't see if you can see this. It's way too bright out here for the screen, but it looks pretty good. You know, it's obviously pitted, but it doesn't fix that. It just eats the rust away, and I can't see any rust left. So that's great. Now, one thing on this guy here, a lot of the paint didn't actually come off with the pressure washing, but that's fine. It's actually on this side mostly, and this is original paint from the underside of this arm. And with how this machine works, that's underneath, so it clearly doesn't get very dirty. Anything that was falling on it's a tire machine, so all the gunk and goop and liquids that were falling on it were on the top, and then the shop ended up repainting it badly, but in any case, and they didn't do the underside, or if they did, it was mostly just covering this paint, so that stuff came off. But this is good, clean paint on top of clean metal, so you know, I'm not concerned about that for what I'm doing. I'm just trying to make this thing nice and in my shop. Now the top part here, this part that didn't come off perfectly, there was a label here, it was all torn up, and there's some adhesive still, so I'm gonna have to touch that up. So I'll do a little bit of fine tuning before I actually paint these things, but I'm very pleased. It's done the 90% or more than 90% of the prep work prior to painting here. So I'm gonna take these in, I'm going to spray them with some WD-40 because I'm not going to paint for a while, so I'm going to dry them off with the air hose, just blast them dry, put some oil on them just to keep them from flash rusting, and then get ready for paint. Okay, so here it is on the desk now. I've got the panel off, but again, all the switches, I put some reminders here for how to mix, and just a reminder not to corrode the wrong part. But anyway, so it looks like a giant rat's nest in here, and it took a long time to put together. But essentially, at the back panel here, you can see you got a positive and a negative going off all those bulbs. That's the shunt for the measuring the amperage up to 100 amps. And I've got this fuse block here with a fuse block. So I laminated some thinner pieces of plastic material. I don't know exactly. I think it's acrylic or something, but anyways, I laminated together and then use that to isolate it from
the chassis, so I don't get any grounding. That block was already obviously like that. And then the power comes out here as one of the hookups. So this is actually the negative, sorry. This is coming in and out there is going out. So obviously you can't really see much from this. So I'm gonna show you a quick wiring diagram that I made, nothing fancy, but that's what this rat nest essentially is. So let's turn on these screens here. So first off, we'll go to this in a second. Pull up this. All right, so as you can see, I've got the power supply positive. It goes to that 60 amp fuse block that I showed you. Then here, I just showed 2 of them, but there's 24 of these. So, and again, there's 2 here. So I've got the switch, then it goes over here and it has a parallel circuit. One goes to the light bulb, one goes to the diode that's on top just to see if it's on. And then those flow out. So all of those, that's where it branches off into basically all the wires that are in there. They go to the switch, go to the light bulb, and then they come back together at this point here. So that is actually right outside the case, right down here. So that one wire there, I actually forgot. So I had to add it in after, and that's the wire that goes to the voltmeter, I believe. Actually, I can't remember. It might not go there, so don't quote me on that. But in any case, that's where they join up. So that's the positive terminal that then you connect over to the electrolysis pit. And then obviously to the sacrificial aspect. And then you've got the part, and then it goes up. So that voltmeter there is the small voltmeter on top. So that's this one here. And what that does is it shows you the voltage across your electrolysis tank. So then up here it goes into the shunt, and then you can see here there's a positive lead coming in and a negative lead coming out. So that's doing the voltage across the entire system. So from that I can subtract the voltage across the electrolysis tank, and then I know the voltage that are going to the light bulbs. But I don't really care about that. I just kind of want to know what is going to the tank and what the overall is, even though it's pretty steady. Now I know it's pretty steady at 12.2, 12.21. So, and then the rest of this wiring here is just for the across the shunt for the amperage, and then all of that feeds back to the 850 watt power supply. So I'm very happy with that and how it's working out for me. So yeah, and then essentially I'd mentioned before about the adding additional light bulbs. So I made a quick graph off some measurements that I did. Okay, so we've got this chart here. So we've got current on the y-axis, and we've got the number of bulbs on this axis here. So I've got 24, so that last point there is 24 bulbs, and then over here you see 40 amps. So this was for a different, I believe I measured this when I did another large part, but in any case, it's pretty comparable. The smaller parts you do, you don't draw this much. You're never gonna draw this much, so you don't have to worry about it. But I wanted something that was capable of doing larger parts to get, approximately 40 amps. I would have been nice to have been able to get more, but essentially I was looking at this graph and it would take a lot of light bulbs to get anywhere close to 70. So I'm happy with 24. So I can leave that running days at a time, and it's never going to hurt that power supply. Well, through wear and tear maybe eventually, but the power supply is more than rated for that kind of power output. So I'm very happy with that. Then on the bottom here you have the voltage across the pit. So it kind of levels out at around 7 volts, but as I believe I showed you in the video, after time it ends up going up to pretty much 12, and the light bulbs go out entirely, even though they're still part of the circuit. So yeah, so as you can see, the most benefits you get are right in the beginning aspect, and then it starts to level off. Yes, it's still increasing, but it is a lot slower, and you're not really getting the benefit that you would get otherwise. So I hope that was helpful. If you have any questions, leave a comment. I'm always happy to help. It took me about 2 weeks of working nights on this thing, so it was just trying to figure out how I was gonna do it. So I modified it a few times, but pretty happy with the end product. So hopefully you liked it and give it a thumbs up. See you in the garage.